So we started recording again, and we are looking at restricted domain for the functions. So what do we mean by restricted domain? So let's find out. Oh, this is frozen. Okay. So when a function involves division, then you know that in division, when you divide any number by 0, what do you get? If you get a calculator and you divide a number by 0, what does the calculator come back with? So anytime if you try your calculator, if you've got a scientific calculator, put any number and you divide it by 0, you can let me know if it works. It should come with a math error. Okay. So that means your denominator can never be equal to 0. Okay. So we've got a restriction here. So you can try it if you type 5 divided by 0. So if your calculator works properly, it should come with an error. Equal. Is it coming with something? It should say math error. Yeah, 5 divided by 0 equal. Yeah, so that means we're restricted. We can't divide something by 0. It's impossible. You can multiply something by 0, but you can't divide by 0. Now, if you got a function that involves square root, so remember, can you do square root of 36? You told me that was 6, but can you type square root of negative 36? So square root of minus 36. What do you get? Again, math error. So whenever you're going to have that math error, that means you're restricted. So you can't square root a negative number. This is at the moment because we're talking about real numbers. Okay. So someone came up with a way to go around this problem, but that's going to be on outcome 3 when we are going to be looking at complex numbers. Okay. So when we look at complex numbers, you'll find out that you can square root a negative value, but I need to show you how. So we're not there yet. So we need to walk first before we start running. Okay. So we need to make those connections in your brain. Learn in small bits, a little bit every day, to make the connections in your brain so that you can remember better when you're going to start doing an exam. Okay. So when the domain of a function is not given, it is assumed to be the set of all real numbers. So by default, if someone doesn't tell you x belong to the whole numbers or the natural numbers or integers, by default, they mean the set of all real numbers. See that line x? It's made of all the real numbers. So every time. Consider this function, 1 divided by x, yeah? So if you've got a function like this, you can see straight away, if you were to type it into, so there's a good, something called Desmos. So if you get the chance, www.desmos.com, if you type 1 of x, it'll show you the function. So if I was to use any value from x, you can see that it's got a corresponding value on y. Same on the negative side, you've got a corresponding value for y. But have you noticed something? If x equals 0, I never touch this function. That's the restriction that we have. Because we can't divide by 0, your calculator will never give you a value if you put x equals 0. Okay? So if x were allowed to take any real value, then we could have x equals 0. But however, we've noticed that when x equals 0, we don't get a value for y. So to make f of x here a function, we've got to restrict its input. We've got to say we can use all the value on x with the exception of x equals 0. And that's what they mean by restricting the domain. Okay? So you'll see it written like this. And if you've done that 5, I'm sure you've done some algebraic fractions where you had something like f of x equal 1 over x plus 1. And next to it, someone will say, but x is different than -1. You always wondered, why did they have that next to it? It just means that in order for this function to work, x can never be equal to -1, because -1 plus 1 would give me 0. So that's why and the teacher kept telling you, yeah, ignore that bit. But that's what I mean by the restriction that you had. Okay? So now it should come a bit clearer. So the range of this function is f of x belong to R, but f of x is different than 0. Okay, so that's what we call the range. We've got a restriction in the domain, and the range is f of x is different than 0. Okay. Now, that was the example with the fraction. I mentioned something about square root. And what did we say? X minus 2 cannot be negative, yeah? So how do you solve this? X minus 2 cannot be negative. That means it's got to be positive, yeah? So x minus 2, here, you would write x minus 2 is greater than or equal to 0. That's the only way this would work. And you remember solving these inequations? So if I've got a -2 on this side, how do I get rid of the -2? So you can move it on the other side, yeah? Remember your teacher telling you, move it to the other side, but it changes the, yeah, so you change the sign. So what they mean really is whatever you do on this side, you need to do the same on that side. And what we did by moving it onto the other side, we've added 2 here. But whatever you do on that side to keep the balance, remember an equation or in equations has always got a balance. You need to do the same on this side. So if you were to teach that to somebody, it's better to teach the person what you've done. You've got a balance. To keep that balance, you do something on the left, you do the same on the right. Because if I add 2 on both sides, it gets rid of the 2. And now 2 plus 0 is just 2. And you've got here x greater than or equal to 2. And as you can see from my domain here, when I plug this square root of x minus 2 as a graph, 2. So x is always greater than or equal to 2. So x takes all these values greater than 2. And when x equals 2, 2 take away 2 is 0. Square root of 0 is just 0. Because 0 times 0 is 0. So then that means that's where we start. Okay? So this is how you restrict it. So because we cannot find a square root of a negative number, the function here is not defined when x is less than 2. And we say that this function here works when x is greater than or equal to 2. Okay, so we've restricted the domain. So this means x can be any real number greater than or equal to 2. The range of this function is g of x. Here the range, looking at this, is g of x is always positive. So the range is the output. The domain is the input. So x for my input, y for my output, and you can see that the square root is always positive. Okay? So you need to remember that. Domain, input, range, output. So for each function below, what is the largest possible domain of f of x? So if I've got, remember what we said? when you've got a fraction, what does it mean for the denominator? So numerator is the top, denominator the bottom. The denominator cannot be equal to 0. So I need to say x minus 3 different than 0. So if you write here x minus 3 different than 0, what do we do to get rid of the negative 3? To move it on the other side or add 3 both sides? Same thing. Then that means this will go and you've got x different than 3, which is how you write it here. Okay, so you just solve that equation and decide here, my domain is x belonging to all, so this sign here means belongs to all the real numbers, but x is different than 3. That's how you would find your largest possible domain. Okay, so here I've got a function which is neither a fraction nor a square root. 2x minus 7. Can I use any x's? So here, remember, it's not a fraction and it's not a square root. That means I'm not restricted. I can use any x's. Yeah. It's only when you've got a fraction or when you've got a square root that you've got restriction. So if I put x equals 0, it works. If I put x equal negative infinity, it will work. If I put x equal positive on the infinity side, it will work. So any x's. So the question is, what is the largest possible domain? It's x belonging to all the real numbers. Okay, so for a function like this, I don't have a restriction. You just write x belong to all the real numbers. Okay, so basically, you answer the question, what is the largest possible domain? It's the domain of all real numbers, starting from negative infinity right up to the other side of positive infinity. And it's only when you see a fraction or a square root that you need to ask yourself questions. Yeah. Now the third one, this time what do I have? A square root. And what did we say for the square root? This needs to be, can't be negative, so it's got to be positive. Yeah. So now you need to write, you need to solve me 9 take away x has got to be positive or equal to 0. It can be equal to 0, remember? So you need to solve me this and tell me what is x here? Where is x if 9 negative x greater than or equal to 0? So how would you solve that? Using your NAT5 in equation. So I'm going to pause the record and I'll give you a couple of minutes and see how would you solve this. Resume. Okay, so like I was saying earlier on, what you do on the left side, you need to do the same on the right side. If I want to get rid of the minus x, I need to add x on each side. That would get rid of this. And you end up with 9 greater than or equal to x. Or you can rewrite that as x less than or equal to 9. So for this function to work, I need to have all the real numbers that are less than or equal to 9. Otherwise, this won't work. If I put 10 here, it doesn't work because what's 9 take away 10? 9 minus 10? Minus 1. And because you can't do square root of minus 1, you've broken the rule. So that's the rule that you have for this function is x is always less than or equal to 9. Okay, so x belongs to all the reals and x is less than or equal to 9. Okay, so we should be back to recording. Okay, so for the next one, what do you have this time? Is it a fraction or a square root? Fraction. It's easier with a fraction actually, because you just make this different than, remember the denominator can't be equal to 0. So you need to solve on your paper x squared minus 16 different than 0. So how do you solve that? Hello.
Good morning.
Morning.
Hello, how are you?
Good, good, good. Sorry.
Oh, we meant to have an awful lot more, but I don't know what went wrong this morning.
Okay.
I think this is, these are the numbers you're meant to have.
Okay.
Names anyway.
Is that Andrew? What's your name? Sorry.
I'm Ras Paul. I'm actually the afternoon lecturer for them.
Okay. I know, because they've told me that during the induction they were told that it probably be online. So what I've done is I'm recording the lesson, and then I'll be putting that for them onto YouTube to be able to access it. Okay.
Is it okay if I give them an update?
Yeah, on you go.
Thanks very much.
No
Hello,
worries.
everyone. I think you've got me this afternoon. We're meant to have Stephen Finch, so I'm going to give you a wee update by taking. Thank you very much. This is what it's looking like now. So these haven't changed. Something changed. Yes, that's fine. It's always going to be there. I don't think this will change much. This will be it. So I'll see you this afternoon upstairs in room 351. There'll be more people coming up.
Okay. Well, once they've been told.
Yes.
Okay. All right.
It's difficult. It's good actually in a way because they were a bit uncertain about an online class and then coming in with me in the afternoon. So now that they know they're in,
that'd be fine. Yeah, I've told them as well, so they should be in.
Thank you for your time.
No worries, me.
Thank you
And I'll see you around. See you. Okay, guys. So we need to solve this x squared minus 16 different than 0. So we're going to move 16 on the other side. So x squared different than positive 16, or we could just call it 16. So what's the opposite of squaring? Taking the square root. Yeah. So remember what I said? Equation or inequation or whatever. Whatever you do on the left, you do the same on the right. So if I do square root of x squared, that gives me x. Yeah. Square root of a square number give me x. And on the other side, square root of 16. What's square root of 16? Remember, we're on the real land. So whenever you're going to see x squared, I expect two answers. Okay, so it's like when you worked with parabolas, you had two answers. Yeah. So what is the answer for x? What are the two answers that would give me 16 if I square them? Plus and minus 4 are your two answers here. Because positive 4 will give me 16, but negative 4 times negative 4 will give me 16. So you've got two answers here. So x will be different. So you can write it like that, plus and minus 4. Okay? Because if you give just one answer, you get half the marks. Because negative 4 times negative 4 is 16 as well. So we need to make sure that x is not positive 4 and x is not negative 4 for this to work properly. Yeah? Okay, so now that you've looked at restriction in your domain, there is another thing that we mentioned as well when it comes to functions. When you represent a function, you will have what we call asymptotes. So I need to explain to you what do they mean by asymptotes. What is an asymptote basically? So let's see the way to do this. You think about an asymptote being something that you're going to come close to but never touches it. Yeah. So how can we, if we look at this function here, you can see that the graph come close to here, infinity on the y side and negative infinity on the y side as well, but the function never touches it. So we call this an asymptote to the function, a vertical asymptote. But can you see that we've got a horizontal asymptote as well? Because that function here will come close to 0, but never touches 0 when x is into the infinity land or when x is negative infinity. So we've got two asymptotes, a vertical one and a horizontal one. And how do we define those asymptotes? So what you do is you say to yourself, as x tend to infinity, you can see that the value of x here, as x gets bigger and bigger and bigger. So if you take 1, you divide it by a massive number, you will get 0, right? It will get closer and closer to 0. Never touches 0, but it will get closer to it. So as x increases to infinity, f of x goes down. As x tends towards that infinity, f of x tends towards 0. Okay, so this is the way to write it. You put x tends towards infinity. The function itself tends towards 0. That's how you write it mathematically. And as x gets larger, we say that f of x gets closer to the x-axis without touching it. And because of that, we come up in maths, we say x-axis is a horizontal asymptote to the curve y equal f of x. So basically, if you can write something like this, as x tend towards infinity, we never, f of x tend to 0, we've got what we call a horizontal asymptote. The same thing happen as well as x tends towards negative infinity, f of x again tends towards 0 without touching it. Okay, but on the negative side. But like I was just mentioning earlier on, we can see as well as x tend towards 0, the value of f of x increases. Yeah, you know that if I divide 1 by a half, what do you get if you do 1 divided by a half? Without a calculator, if you were to do 1 divided by a half, what do you get? Yeah, because in one part, how many halves can you have? 2 halves. Yeah, and you've been told by 1 divided by a half is just 1 over 1 divided by a half. And when you divide two fractions, you've probably been told to flip the second one and just change the divide sign by a multiply. So that's what you've been told at school, but that's where it's coming from. So if I flip that second one, it becomes 2 over 1. So 1 over 1 is 1, 2 over 1 is 2, 2 times 1 is 2. Okay, so that's where it's coming from. So when someone tells you, when I divide, my number gets smaller, it only gets smaller if you divide by a number greater than 1. If you divide by a number less than 1, like 0.9 or 0.8 or 0.5 and so on, when you divide, you're going to make your the output will become bigger. But at primary, you've been put into your head a misconception as to dividing means make it smaller. Not always, only if you divide by a number bigger than 1. So that's what you need to remember now. So all those misconceptions, you need to take out of your head and try to say, oh, but when I divide by a fraction, my number gets bigger. Okay? So as x tends towards 0, f of x here will get bigger and bigger, which is what we see in the graph. So we put a wee minus zeros. That means you tend towards 0 on the minus side. So as x tend towards 0, but on the minus side, you see f of x going towards negative infinity. And as x tend towards 0 plus, on the plus side, you've got f of x going towards positive infinity, right? The same thing. Okay, so you'll see me sometime writing 0 with a positive next to it. That means close to 0 on the positive side, close to 0 on the negative side. So now we write that y-axis is a vertical asymptote. So now you know where asymptotes are coming from. It's to do with how the function behave as you tend towards a certain value. Okay? So an asymptote is a line which a curve approaches to as it heads to infinity. So as the curve is going towards infinity, it approaches a certain line. Okay? So that means you'll be able to look at worksheet number 2 and do exercise 1, 2, 3. So you've got 3 exercises basically. And you're just going to apply what you've just done. So state, so page 17. So on page 17, you'll see f of x equals square root of 3x plus 9. So they're asking you to state a suitable domain. And you know that 3x plus 9 needs to be positive or equal to 0. So you need to solve 3x plus 9 greater than or equal to 0. Yeah. And when you've got a fraction, the second one, b, we've got 4 over t square. That means t square can't be equal to 0 or t different than 0. So fraction, the denominator can't be equal to 0. Square root, whatever you square, it's got to be positive or equal to 0. So you do that for these functions. Let me know how you get on. A function is given, so you've got 2. Write down the value of the function if x tends towards infinity. So look at 5 over 4x squared, for example. If x is huge, then 5 divided by a huge number will tend towards 0, yeah? Then that means f of x will tend towards 20. Okay. For the function state a suitable domain, find the value of f of t when t tends towards negative or towards infinity. Okay, so those are the 3 questions. And now we're going to skip the third part. We're going to move to page 26. So if you go to page 26, so we'll come back to that part next week. The composition of function, we'll look at it next week. So what I want us to check is, what do we call the inverse of a function? Okay, and when do we do that? So we've looked at a normal function, remember? Where you've got an input, you've got an output. We call that the domain. We call that the range. Sometimes you've seen it said image, and you had your function. Now, what do we call the inverse of a function? Remember, you used to see that f with a -1 as an index, f minus 1. So that's what we used to call inverse. So when you had sine of a certain angle is half, the inverse sine was sine minus 1. So on your calculator, it's just above the sine. So if you've got the sine for sinusoidal, you've got inverse sine, which is this, yeah, so you do shift sine. So that's what an inverse of a function is. So basically the inverse of a function will take your output and will give you what the input would be. It's a bit like working backward. And in electricity, electronics, you will have to find things like that, because sometimes you will have a function where you need what we call a loop back mode, where you need to find what is the output of your function. But then the output, if I put it back inside my system, what do I get? Because that might decide what I need to retune math function with, so we've got what we call a closed loop circuit, where you keep taking an output through your function using the inverse of the function to be able to decide what do I need to tune automatically. Okay, so that's important in function land, especially if you look at electronics work or electricity. Okay, so we call that f minus 1 with a v minus 1 on top, and that would give me back my input that we've called this time an output. So if I ask you to find the inverse function if f of x equals 3x, so what would be the inverse of multiply by 3? Divide by 3 would be the opposite, yeah? So the inverse of a multiply is a divide. But then, is there a way for us to find this quite easily? So I'm going to give you a tip how to do these, right? So remember what we said, f of x was just your y axis when we looked at y and x. So if I put y equals 3x, if I divide both sides by 3, what would I get? Now, I want you to, remember you did this thing in class, changing the subject? So that comes handy here. If I tell you, I want you now to make x your subject. Remember, it used to be y, input. My output was based on what I do to my input. Now, I want you to change the subject and make x as if it was your output. So you divide by 3 both sides, and you will get x equal y over 3. We've changed the subject. Okay? And to do that, I use my balance analogy. So what I do on that side, I need to do the same on that side. So if I divide by 3 here, what's 3 divided by 3? Yeah, it's got to be 1. How many 3s could you fit into 3? Just 1. And how do you write 1x in math? Just x. And then y divided by 3, just stay y divided by 3. So x equal y divided by 3, which is, you can rewrite it that way or that way, doesn't matter. Now that I've got x equal y over 3, what you do is you replace the y and you make it as an x, and you just say that f minus 1 of x is just x divided by 3. So two things, make x the subject, and then to write f minus 1 of x, because it's not f minus 1 of y that we're looking for, it's f minus 1 of x. You just change the y and make it as x. And that's you've got your inverse function. But it was very trivial that we knew the inverse of 3 times x is just x over 3. But that's the way to do it. On a simple example, I've managed to show you how to do it. But tomorrow it's not just going to be x here. It's going to be 3 times x squared plus 2x minus 6. Then you're going to have to change the subject. That becomes a bit harder, but you've got a technique to do it. That's why we teach a technique onto something very simple, so you know where it's coming from. Okay? And hopefully your visual memory will say, oh, inverse, I need to change the subject, and I need to remember to switch the y into an x at the end. Two things to do. And that's how you learn. That's how you look at your short-term memory in class, and you put it back into your brain in your long-term memory, and the day you need it, it will come back. Yeah? But then in order for it to become more accessible, you need to do what? Guess why Tiger Woods is very good today? What do you think he's been doing since he was 3-year-old? Practice, 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 practice. So if you want these to stick in your head, when I tell you, I've given you some homework to do, don't wait 5 minutes to do that. No. If Tiger Woods were waiting just the day before a tournament, oh, I'm going to do this, he'll never be good. And it's the same for anything you do. If you want to become good at something and master it, you need to apply it for your brain to be able to now stick what you've learned. If you don't practice, I can guarantee you, you will forget. Yeah? There's no two ways about it. Your brain is a massive energy part of your body. And if your brain thinks, I'm not going to need this, when someone gives you a number, phone number, that you think, I'm never going to call that person, what do you think your brain is telling you? Don't put it in my memory at somewhere where I need to call it back, because that sucks energy from you. Then you forget it. Okay? Whereas if you want to remember it because you think you're going to need it, you will need a bit of energy from you. Okay? And that's the last part of your body that will shut down if you were to die, for example. There are a lot of other organs in your body that will wait. For example, if you're on a desert and you don't drink for days, you'll find out that your kidneys start to shut down because your energy is needed by your brain to function. Because if your brain doesn't function, what do? You just sleep and die. Yeah? So now we know we've got a way to do things. Same thing here, find the inverse function given if f of x equal x squared. So I need to change the subject again. Yeah? So you write first y equal x squared, yeah? So what's the opposite of squaring? Take the square root, yeah? So we need to change the subject. So then x becomes square root of y. And then to write f minus 1 of x, you change the y into an x. And now we've got our answer. F minus 1 of x is just square root of x. Two things, change the subject and then switch the y into an x. And that's you. You've got the inverse of your function. Okay? So find the inverse function given if I've got 4x minus 1. So again, think about it. We've timed by x, we time x by 4, and we've taken away 1. What's the opposite of taking away? Add 1. And then what's the opposite of multiply by 4? Divide by 4. So we need to do two things. We need to add 1 and divide by 4. And we have the inverse of a function. So how do we do this? We change the subject. So if I ask you y equal 4x minus 1, change the subjects to x, then first of all, we add 1. You get y plus 1 equal 4x. Yeah? And then what do we do after that? We divide by 4. Things to be careful with here is, remember when I did here y plus 1 equal 4x? To give you a tip so that you don't forget, put that there. Because now if I divide by 4 here, that goes, you need to divide by 4 here. You'd be surprised how many people just put y over 4 plus 1. So you divide the whole section. Here, 4x, we've divided the whole section. We've not just divided 4 because it's 4 times x. Okay? So a very common mistake, people forget the 1 and just put y over 4 plus 1, and then they lose the mark. So if you don't want that to happen, put brackets, and then that might you might remember it better. Now, what's f minus 1 of x? I just switched the y into an x this time, yeah? And I get my f minus 1 of x is just x plus 1 divided by 4. Okay, so we've got a technique. We need to practice it. And once you've practiced it, you become better at it. And to practice it, it's in worksheet 4, which is page 37. Okay. So you might need to read, to answer these questions, you might need to read a bit more on page, the graph function, the graph part. So you will need to do a bit of self-learning here, where you've got to sketch. So in order to sketch, you will need to look at page 27, 28, 29. So if you look at page 27, 28, 29, it would help you to sketch these. Okay, so use your teaching material in order to answer all these questions. Okay, so now you went to a level where, okay, you've got me on a one-to-one on the Monday morning, but you need to do a bit of self-learning, right? You need to own your own learning, and that's the best way for you to learn. It's not just to listen to someone. It's for you to practice, to read, to try, to communicate back to me and say, look, I'm struggling a wee bit with this. Because for me, the best way to learn is through making mistakes. Yeah. When you see babies started to walk, how many times do you think they fall on the floor before they can master the walking properly? It's just through the mistakes that they make, okay? So I would rather someone make mistakes when we're in class than when they are in front of their paper during an exam, because that's not the time to make those mistakes, okay? So if we adopt that strategy, you tell me what your brain is telling you, and then we can discuss, because sometimes what you think, maybe some other people thinking it, and then we'll learn better that way, okay? All right, I think I'm gonna stop the recording.